These are like a couple of the problems in the homework this week, so I figured I'd walk through some of these odd-numbered exercises, at least one of each, so to get you an idea of how to proceed this. Now, these are out of context. These are just pretty raw sig tests, significance tests. Now, what they aren't telling us that anything about HO. So what HO will be in each one of these cases, it'll be equal to. So if I'm looking at number 13, the HA test is less than 75, so HO will be equal to 75, because that says there's no difference. So 75 is the mean in the middle, that's the center of the sampling distribution. Now I want to know how likely is it to get a value less than that. Okay, that's the p-value, what I'm looking for, or if I'm going to use the critical value method, it has to be less than some z-score. So because this will be 0, this z-score will be 0 for the mean, and I'm going to find another z-score for the sample result of 70. Okay, now I know the sample size is 100, so I got to get the standard deviation for this sampling distribution. Standard error is another name for it. So since the population standard deviation is 15, right there, I'm going to divide that by the square root of 100. And that'll be my standard error, the standard deviation for the sampling distribution. And the square root of 100 is 10, so that gives me a z-score of 1.5. Okay, and actually, standard deviation of 1.5, sorry. Now I got to figure out the z-score for the sample size of, there's 100, they sampled 100 whatevers, they got an average of 70, so now we got to get the z-score for that. So z equals 70 minus the mean of 75 divided by 1.5, because that's standard deviation. So negative 5 divided by 1.5 is negative 3.33 with a whole bunch of threes. I'll go 2 decimal places. So now we've got to decide if we're going to use the critical value method. We got to figure out if that is outside the critical value. In fact, I'm going to go to another slide and talk a little bit more about that. So to figure out whether we're going to reject HO or not, what we have to remember is that the central limit theorem says that these distributions will fall in a normal distribution, shape of a normal distribution. They'll have the center of what we're thinking it is. In this case, the center will be 75, and then the standard deviation will be that standard deviation divided by the square root of n. And we've already done all that work. So we even came up with a z-score of negative 3.33. So now we're going to ask ourselves, is that within a reasonable range to say that 75 is still the true center, or is it not? Is it different? So the one way to do this is use these critical values of z's, and these are like a fence or a gatekeeper. And if your z-score gets out of the fence, then you can say, well, HO is wrong. That 75 is no longer we don't think it's the true average. So what we do is this is just part of the z-score table there in table A. We're doing a 5% level of significance. We're doing a left-tailed test because HO or HA was less than. So our cutoff or our fence is negative 1.645. So this is negative 1.645. Now what that does is anything to the right of that will be a happy place. I got a colleague that words it this way. That's the happy place for HO, because that says HO is correct. We can't say that HO is wrong. It's satisfied. Everything's acting like it's supposed to be. But when this z-score that we got, this negative 3.33, that's out here. It's out beyond that cutoff, that critical value. So this area out here is the rejection region, and what we reject is HO. HO is no longer happy, so to speak. It fell out there. It's what this means there's evidence that the HO is not supported. So what we would say would reject HO, and then would have to put it in context. Of course, it's hard to do it with this contextless question, but that's how you use these critical values. Let's do a couple more. Let's take a look at number 15. 15 is a little bit different. 13 was less than, and 15 is HA is a greater than. So what we're looking at there is if the mean is 12, we're trying to determine, is it high enough? Is that let's see, what is the sample average? 14. Is 14 far enough away from 12 to say that something's going on here? If we use the critical value method, we're going to figure out the probability of being that far away from the mean. So first off, we got to convert these all to z-scores. So let's see, the standard deviation with the sampling distribution is going to be 2 divided by the square root of 64, because 2 was the standard deviation of the population, and we had a sample, we're working with sample sizes of 64. So 2 over 8 is 0.25. Now we're going to get the z-score for this situation. So the sample mean was 14, population mean is 12, our standard deviation is 0.25. Well, that's a difference of 2 divided by 0.25, I believe, is 4. Okay. So now we got to decide, is that far enough? Is the z-score 4 far enough away from the middle to say that something's going on here? And I think you'll hopefully get a sense that, yeah, it is. It's a lot more than 3. But let's go look at that critical value table. So looking at this critical value table for a 5% level of significance, we've got a right-tailed test because HA is a greater than. That tells me I have to be 1.645. Well, that's a lot bigger than 1.645. So this did fall into the rejection region. Okay, remember the 1.645 is the cutoff for the happy place for HO. If that z-score was down here, HO would be happy, but since it's out beyond here, z-score of 4 is way out here, so we got to reject HO for this situation, and looks like the mean is not equal to 12. So now we're going to take a look at number 17. 17 says that HA is not equal to. Well, that's a two-tailed test. We don't know whether it's differs or whether it's greater than, less than. We don't know. So what we've got is we've got two situations. We've got a negative z-score and a positive z-score that cuts off and denotes the rejection region. So anything in between them, we won't be able to reject HO. So let's see, for 17, they're telling us, well, I'm going to write HO and HA. That's what I'd like you to do, especially when you're dealing with these things in context. So HO is, nope, the middle is 2.55, and HA, they're telling us, is it's just different from 2.55. So we're going to find a z-score again. So let's see this. So the standard deviation for the sampling distribution, or the standard error, is going to be, let's see, 0.29 divided by the square root of 100. I think I get that right. Let's see. There's 0.29 and ends 100. So now let's see. So that's 0.29 over 10. So that's a very small standard deviation of 0.029. So then to get the z-score for this situation, let's see, the sample mean was 2.58. So 2.58 minus what we think the population mean is 2.55 divided by 0.029. So that's the difference of 0.03. I'm going to divide that by 0.029. So that gives me a z-score of 1.034. It's probably enough decimal places. Okay, so now we're going to decide if that's in the rejection region. So I'm looking at a two-tailed test. I'm looking at the 5% significance level. That's a cutoff of negative 1.96 and positive 1.96. So these z-scores right here are negative 1.96 and positive 1.96, and our test statistic isn't out that far. 1.03 isn't far enough away from the middle to say something's going on. So we can't reject HO. We can't say that the mean's different from 2.55. So you see the way that that test statistic from the sample didn't land in the rejection region. Remember, the rejection region are the tail areas, and this is not.